Hello, what's up? I'm Junchan and welcome back to the stream. What's new? Well, nothing. Let's just get into it. Okay, I'm glad you asked. All right, so what are we doing? Well, we're continuing with our streaming tools and our crazy free arrows because, why not? That stuff is interesting and I'll probably do this again on Saturday, but then next week I'll change because we need to cap things in order to breathe a bit, right? This has been the 1, 2, 3, 4, 5th. So yeah, so it's not too extreme. Okay, right. So the thing we were looking at was to try and find a base f that makes sense. So what does that even mean? Well, it means that right now we crafted this H identity as a kind of f, right? Because that's the name of our type parameter in HH3 arrow FAB, which is the same thing as free A FAB. So the question is, what about f? Like this H identity as a choice of f is a little bit strange. And here in HH3, both f and r are bifunctors. So they have two type parameters, and so each identity was my attempt to do like a basic bifunctor. But you know what? That's not a bad place to start. Let's just try and see, for instance, what maybe Bartos says about profunctors. Not profunctors, bifunctors. Let's see. Bartos and bifunctors. Reality, bifunctors. Since functors are morphisms in cat, a lot of intuition about morphisms apply to functors as well. An object, a bifunctor maps every pair of objects, one from one category C and one from category D to an object in category E. And E is the Cartesian product. No, the mapping is the Cartesian product, and E, I think, is the product category. And we have by map, and so either is a bifunctor, for instance, which makes sense, as well as product or pair, the simplest product type. Is that the simplest bifunctor? What if we try to do pair? So that would be what that wouldn't even mean anything, would it? Hold on 1 second. We could have pair here, and then we need to construct a pair. But we don't really care so much for that. And I have the intuition that, well, so f is supposed to be something in the video. It's supposed to be something that that's like MTS style with type classes. And I think it should mean that f could also be monostack transformer style. Could it be though? Because f is not a monad. F is an arrow. I mean, f is not an arrow. F is a bifunctor on which we don't have constraints, right? No, we don't have constraints. It's just like the source bifunctor of a natural transformation. Okay. I'm not sure we're gonna get much help from here. Maybe maybe we need to browse a bit through the video. Try and find something. Oh boy. Oh no. You're not gonna give me an advertising. Okay, yeah, that's at the end of the world. How do things look like here? The lift F. Ah, right, okay. Yes. So this is the way that I think an open, what is it, an open sum type? An open type level sum type is basically kind of a record type replacement, I think, that allows to do the MTL thing, I believe. Right, this thing where you where you just keep an open F, and you say that this open F actually contains a printx effect. So I think I haven't really decided whether I wanted to do this kind of MTL style thing. It seems like probably a good idea. This just lifts print. We go from text to unit. Okay, I think this is actually pretty important for us to copy that. Okay, so I'm going to give another shot at trying to find this code somewhere, because I think we found something a bit more advanced even than this, but the examples weren't there, I don't think. But let's just bring this guy in the fold here and try extensible arrow, and we're probably going to want to do that inside GitHub. Better extensible arrows. Okay. And yeah, so let's go do that in GitHub, as I mentioned, which shall be easier. And yes, okay. All right, that's not going to be nice if I have this each time great, notes, fantastic. Yes, so give me the extensible arrow right here. Fantastic. Oh, thank you so much, RTNP. That's really cool. And we're gonna check out your GitHub. Are we here? And yes, I haven't paid my bill, I know, and you're totally outing me out on stream. Right? I'm outing myself. Let's not take responsibility here. Okay, cool. I don't see a lot of Haskell here, actually. That's interesting. C++, Spark for C++, yeah. And okay, some Haskell notes, and oh, semantic. I remember seeing that. That's pretty complicated. Okay, so that's pretty much the only thing here, and notes from lambda-conf. Very cool. They are really well done notes. And what's this? It's the same thing, right? Different Even commit? No, same. Update 2000. Yeah, no, it looks like it's the same. Commit 184. Commit 184. Yeah. Okay, so we have code which allows us to copy paste instead of trying to decipher this very difficult to read thing. So let's close this and let's close this and let's look at it again. That's a little bit strange here. It must be imported from something, I imagine, maybe. Apply Fanon and split. Interesting. Compile A. If I classly lift K. Lift K is the thing that takes the B2MC and creates the free classly. Did we get that correctly? I think we tried to think about the classly stuff last time. Well, not here, apparently. I was pretty sure I did, but not so. Yeah, I mean, this whole thing is a bit more tricky. Did I have this in design? No. Did I have this in the log? Well, I did have. You're trying to match whole word. That's what is going on. Okay. And same here. Okay, so we do have classly and run classly. That's in design, and right, that was with the free arrow. That was with the free arrow design, I believe. Yes. So all of this was where did we get that from? That is Piponese, yeah, that is Piponese stuff. So we were also interpreting, yeah, that's not exactly the same thing here. Although component could be our F as well. I remember being a bit confused with that. So if component is our F, it seems like with this approach we only need to define the interpreter, and we wouldn't, or the whatever this is, right? Compiler plus interpreter, and then we actually wouldn't need to make our F a perfunctor or a category or anything like that. So maybe that's the way to go. Except that that's not my thought of what an F is in the extensible context. But maybe we should try and play with F being a little bit closer to what we had in Piponese code, and see whether we get anywhere. So maybe I'll add this. That's a base F that makes sense instead of variation density. Right, so we're going to try two things. We're going to try component as F, closer to Piponi, but without writing the instances. And then we'll try something more effecty. Okay, so right, so we take design, for instance, and we'll take our component, but without the instances, and that's going to make a big difference, I think. Didn't I have the component already here? I did. I had a simpler component. Yes, it makes sense to start with a simpler component, and then to say that Well, our program, we might keep our thing, but our program will be component. And so the thing won't type check, and that's fine, because we'll need to create some of these load store and ink, right? So did I have those here? I started to kind of maybe have them. Yes. So let's category F. Okay, I think I was trying something there. That's probably not what we want here. Okay. So that was what yeah, I remember trying to go this route. Right, so there isn't such a thing as nil these days for us, unless, well, nil was part of the constructor. No, it was not. Nil was pup of ID. And this was what? This was the constructor for something that went from the perfunctor AX. Oh yeah, there was this kind of interesting coend thingy there. I think that's a coend, I'm not 100% sure. Do we have a nil, and do we have something like this? I mean, in the new representation, clearly we don't. It doesn't mean, though, that there isn't something equivalent to nil. And that will be for any let's try and see what that means in our context here, see if we can make sense of it. I doubt it, but we can try. The instances, really, that's not telling us much. Record syntax. Okay, you know what? We can find this when we need it. And however, this is what we want. This is the actual definition of HH3 and the natural transformation. So then what would nil look like? It would need to be a free A P with a perfunctor P. I think we needed the perfunctor P because, no, not because I suppose it wasn't enforced at the data type level, which is, I think, the common practice. But morally, I think we expect P to be a perfunctor here. So what? So in our case, this is really F, right? So we need some FAA. And can we create that with some kind of like identity natural transformation? And maybe, so nil will be, let's call it HH3 arrow FAA. Can we do such a thing? So it would, what would it be like? Oh, it could be ID. No, that's not. Well, it could be const ID, to be honest. Well, it could be HH. Oh, hold on. Is thing nil? It is. Wow, amazing. Amazing. So it makes sense. So is that a thing? So now the question is, does this constructor mean anything in our case? And here, given how it's used, is it just, what is it? I was going to say, is it just like arrow composition? Might be that. But no, I don't think so. Here we were pre-composing or post-composing on one end or the other end. And the advantage of this is that it really felt like a linked list. Here, I suppose it's still a linked list, but it's a continuation. So maybe we need to get used to transforming a list into a continuation, which feels like church encoding somehow. Maybe? I don't know. Right, because church encoding, we encode numbers as sort of like function calls. I mean, because I'm thinking something like, because I'm thinking this is using continuation passing style, I believe. And I think the key to that, it's like a kind of higher order, maybe, continuation passing style, where we pass a natural transformation instead of passing a function. And that's somehow, well, it's a bit more nested than that, I think. Because pass a natural transformation. Oh boy, this is all very mind-bending. I'm thinking about this thing. Well, here, yeah, what was I trying to do here? I was trying to reproduce something that was in the Stack Overflow post, I think. Here, the instances. Right, so ID is const ID. So that's part of the, so we don't even need to create a nil, because that's just ID in the category free AF. So this is, I think we have category instances already for free. I mean, for free. There are, we get them from HH free, don't we? That's just H free. And we get category blah C. Hold on, what is this? Superclass 1. Holy moly, this. This is all because it's parametric in C. And that means that it's using like some super complicated thing. And this is also actually parametric in C. Yeah. And so is this, right? So I think if we say, let's try to understand it. Right, so this is for something with only one parameter, and this is for two parameters. And so if we say that C is arrow, which is what we want, then does this mean that we know the star, we apply category this is hurting my brain. What does star? I haven't seen star in instances, to be honest. Okay, let's start with something that doesn't have star. So arrow C, but I thought C would be potentially arrow. So where would we have a arrow? What? This doesn't make any sense. I mean, maybe it does. Is there some higher level arrows? No, it doesn't feel right, does it? Arrow C. Mm. Two arrow instances, and then both our categories a superclass. Okay, let's try and understand what superclass does. It's also in free functor. Superclass BH. Proof that B is a superclass of H. Oh, look at this guy. No, not the same. Okay, so it seems like if I want to understand this, first I need to understand this notation. Okay, we also need to check out has superclasses. Okay, that's also in free functor. Oh, has superclasses is right here, and superclass 1. Oh my, superclass 1 is that H and B both have superclasses, and that the set of superclasses of B is a subset of superclasses of H, plus is subset superclass. So this is, I think, this is because doing type level or constraint computation or expressions is always a bit more verbose than you want them to be, I think. Is subset. Okay, so that's also built up. Those are all basically proofs and ways to have the compiler satisfy the constraint. It's basically logic programming inside the constraint, inside the constraints. So is subset requires a subset as B's. Okay. And then gives you, or has some instances for K is a subset of, what is this? Is subset K is a proxy of X. This thing is a proxy of A's. And then that's a proxy of B's. Holy moly, this is hard to read. What about this? This definitely has two things. And these two subtypes. Well, yeah, this has also three arguments here. So I'm not sure I understand that. Wow. Yeah. Pretty heavy type level programming here for me. Can't say I'm very well versed in all that. Have a type level list. I think I get the gist. Maybe enough to be a user, except for, okay, let's take a look at, I'm still not really understanding the how to read any of that. Has superclasses. I think this is a kind annotation, but it might be okay. Haskell constraint and kind annotations. I'm not sure it's constraint kind. It might be, but okay. So not here. Okay, let's check constraint kinds. Class blah. Yeah, no, constraint kind just allows to say I mean, this probably uses constraint kinds, I would think. CPS, and if we define something that's a constraint, like here, so that requires constraint kinds, and so that's this, the family subset, and this probably also it returns something that needs wow. That's also like, that's a list of continuation somehow, something like that. Maybe that's a way to do a list. I need to look at something for Haskell lists and CPS. How do we CPS a list? This is possible, I think. Haskell CPS, filter, backtracking, const stuff. List A, yeah, but sure, but I'd like it. Maybe I can understand the monad transformer version, but it'd be nice to see a simple version first. Free.co-free.io. I like this, and this is from 2020. Pretty awesome. List, const lists, free monoid, dlist. Yeah, that's kind of what I was thinking, that this is actually a dlist. And isn't a dlist something like CPS? It is not, is it? List of A to list of A. A collection of supporting functions for, oh well, that's just a list of functions. So from list, where is it that I saw dlists recently? I saw it in a YouTube talk. I was making comparisons between dlists and something more advanced. Or was it? Yeah, I think it was dlists. Can't remember. List. Okay, let me check out my YouTube history of screen. And library, history, and search. Haskell or something. No. CFP. No. Okay, looks like I'm going to have to scroll for a bit. Extensible free arrows. Not there. No. Okay, I feel we must be approaching. No. No. And uh-oh. Is that... Oh. Right. It's one of those two. Either lazy graph processing in Haskell or functional programming with structured graphs, I think. Let's check. Lazy graph Haskell. Doesn't look right. I don't think that's the one. And programming structured graphs. So that's actually the parametric higher order syntax stuff. I've been also looking at this. That's in some sense, it's not exactly the next step after this, but it's a potential step where instead of arrows, we go to parametric. Parametric structured graphs. So that's been relegated to the bottom, but it's spiritually the next step, so to speak, where we actually compile a language that that really has arrows, which is maybe not so far from what we're doing with free, but it's much more explicitly about having a compiler. But is this where there was something about difference lists? You know what? I'm not so sure anymore. Probably not. An old idea, but I don't think this was really compared to difference lists. I think it must be another one. Yeah, so that one is pretty intense. Maybe we'll try it, but not for now. Okay, so we continue our journey down me looking at my phone, the very interesting YouTube content that you are all expecting, and Twitch content, of course, if you're watching this now, but you're not watching this now. No, you're not. Okay. All right. Okay, I kind of want to check this out, although this doesn't seem like the right candidate, but it's not impossible. I mean, welcome. Dominique Orchard, famously the author of the co-do notation in Haskell for comonads, and apparently doing some work right now on graded monads, which is a way, I think, to introduce very granular effects. It's the way that I can remember it, although I haven't done any detailed implementation thinking about this. Okay, not this for sure. We continue. Let's do 2 more. Okay. Functional reactive programming. I'm not going to do that. I watched too much YouTube, I gotta say. Graph theoretic perspective on reasoning about time. No, I don't think that's it. Oh, approaching the Yoneda lemma. Okay, I'll cheat and I'll check it out here.
Oh, we need to set. Follows the this is
yeah, no, definitely not that. Wow, much older than I thought. Different lists. Which I suppose would explain why I wouldn't remember it, though. Maybe giving myself a pass on that. Maybe. Well, the fact that I don't find it doesn't mean that I really watched it a long time ago. Could be that I didn't find it, or that I didn't watch it in such a way that it would be in my history. Yeah, we're getting really far back in time here. Okay, last one. No. No. Okay. Okay, after this fascinating content, let's go back to thinking about lists and CPSing of lists, because CPS list. What about that? Yeah, no. Okay. Continuation passing style lists. Small classic example, list length, recursive version adding an accumulator, 1 plus list length. Okay, not clear. Okay, fine, Haskell. List. Every functions do not return values. Suspended computation. A function with general type A to R to R. Given another function as an argument, produces the final result, which clearly is indeed A to R to R, given that these are ABs, in fact. This is for FAB, GAB. So this is definitely a kind of high order continuation passing style. Here we pass apply to, which has this, because that's waiting for function. Hold on. How is that the type of this? Okay, let's look at the type of apply. A to R to A to B. A to B to A to B. Right, so it takes an A to B and an A, and then returns a B. But we've got some kind of flippy thingy going on. Because we gave it, if we do $2, because it's infix, that's the 2. Right. Okay, so therefore we have A to B, A to B. Yeah. Really not the best example because it's hard to define the type there or understand the type, but okay. And fine, but okay, thrice. Then it directly goes to the monad. And there's really nothing about lists. I mean, I might be just, hallucinating and whatnot. Monoid CPS, what's that? The monoid value A can be embedded into and projected from a CPS computation of type unit to A to A. Every monoidal value So that's is that just because unit 2a is isomorphic to A? Projected from a CPS computation of type blah. So A to A to A. Okay, that's the from, right? And that's the to. Okay, yeah, so that's the isomorphism. And you just say, right, okay, so you use the apply there to provide the unit, and then you just mapend and you get the A. So it's just like some wrapping and unwrapping and passing of units, or or giving whatever is expected to the function. And this is a bit of a mind bender right there. So how do we do that? We get a function, but it looks a bit like what we were doing right here. It looks very similar. Yeah, or even here when we're doing const ID here, and what we're trying to do here. So it's an important pattern. And yes, what also seemed to be fairly similar to this pattern, right? We get a k, which in this case is CPS, and then we apply the k to something else. Get the k, apply the k to a thing. In this case, ID blah, or yeah, this second for the pair. Now I'm starting to think, well, this obviously can be used to go to a list, right? Back and forth a list, because list is a monoid. It's a free monoid even. But the fact that it's a free monoid, is that going to, I think we could also bypass the monoid probably by transforming this into cons. Mapend into cons and memT into nil. Do you want to try that? We do want to try that. We're gonna have trouble compiling, but heck, we don't care. So list to CPS will take a list of A, and is that going to take, no, not a list of A, is it? Maybe it is. Maybe it is like a different list. What's a unit to list of? Is it a unit to list of A, or well, yeah, it has to a list of A. So I don't know if that's really interesting. So we would take the list or A's, and it would const A's with yeah, it would const A's with the application of unit. No, it would need, right, okay. So I suppose we could maybe bias this, and is that a thing? It's not a thing. Could be because we actually need to do the composition here. No. So A's is a list of A. That's fine. Okay, do we want to try the reverse? Is that maybe our accumulator? It is. And does this work? It does not, but does, yeah, no, okay. So, okay, let's try and compile that thing. this we can temporarily say that it's this, sure thing. The fact that H identity, we discovered this is nil. Ah, right, so we discovered it's nil. It means that it actually works for any f. It does. It works for all f's. So let's try to compile the guy. So design. Location T. Oh yeah, we don't have a T, so let's pass it unit. And we want to pass it time. Let's pass it 0. No instance for numpad arising from 0, 1 in 174. Yeah, I think I was trying to do something weird here. I thought I actually succeeded in doing something weird, but let's just comment out the whole thing. And let's not do the exec, or let's go fetch back the original exec here. Ah, was it exec prime? I think it was. So we didn't need, why didn't we do normal exec? I'm not sure why we didn't do normal exec, to be honest, but we have it. I mean, it's called exec prime here, but let's establish this, because we kind of probably don't want to have oh, but right, we have sources and sinks and transformers, and I mangled that code. Why did I do that? Okay, so I suppose we need to try and fix the code. And I think maybe just needs this on one side, and then we can't read. Read. No instance for read pad. I see pad isn't pad int. Pad is, oh, pad is pad text. Okay, so let's make pad int for a second. Pad type pad equal int. And we're feeling better here, I believe. And that's what? That's a warning, and that's an error. Okay, so the error is in HH3 arrow, and variable not in scope, exec prime prime. Yes, indeed. So what are we going to do here? We only really want to compile, maybe not. Let's do HH main equals print hello for now, and see what that gets us. Gets us hello. So list to CPS, which looks quite like CPS to lists from this angle. Yeah, I'm not sure what I did there, really. It takes a monoid, lists from a monoid, and gets or is it that it takes a monoid and it returns something CPS that is this? So in our case, we just take an element, so that's not going to get us very far. So we're going to need to map in instead of consing. Or concat. Maybe that's fine. If you want to try this, so it's basically going to be the same. This from monoid. And we just say list of A, list of A, and list of A. And we compile, and then we try it out. So how do we try it out? We get into a do block. And we say fine. Well, we're not, yeah, the thing is that we're not going to have a representation of list to CPS, of the CPS version. So let's first get our list and make it 1, 2, 3, 4, 5. And then let's list to CPS of list. And then what return arrow, and why aren't you happy here? Because now it needs to be applied. Right, because now it has this type, plus it's pure. Okay. So we say we're fine, then CPS is this. And what's wrong with 1? Well, it's just, okay, it's because we don't use it yet. And so CPS now is this a thing that in theory I can just like pass a unit to. And no, it's not true. I need to pass it a function from unit to list. Okay. So what, I ignore it and I return the empty list. And then that's what? Yeah, then that's something that potentially we could print, maybe. Could we print it? Maybe not. No, because you say, what was the type? No, you say list of A. So what? So print. Why not? If it's a list of A. Okay, I'm not reading this. Okay, really? You might want to build. Okay, maybe I'm not running the hello. I think I'm running HH main. No, I should be. Why aren't you recompiling HH3 arrow here? What's up? Yeah, clearly I'm not sure what's happening here actually. Let's re-enter our shell. It's a little bit strange. This is the warning. So it's just, it doesn't recompile because it knows there's an error. Might be, okay. Use const. Is that it? It's not a warning, right? It's an error, no? No. In fact, no, I don't see errors. There's only warnings. Oh, why aren't you recompiling? Clean. Oh. And so if I say 0 here or 10 more, like, are you going to recompile? You're not. This is annoying. It's because I don't have a HH3 arrow as another module. How does it even compile then? I don't know, and it works now. Okay. Okay. So indeed, it is possible to do lists in a CPS style. Let's try to understand a little bit better what that means. So when we do list to CPS, what happens? Takes a list, and creates something that has the list in it and that is ready to be appended to whatever gets given which is going to be some kind of f, and f with f having a type of unit to list of A. So this trick makes it so that we have f of units being called, and that gives us a list of A, and then boom, we append. I'm just thinking that's not so interesting. If we do it in bulk, I think it's more interesting if we do it in somewhat in iterations. How do we do that? We start with list 1 with a 1 in it, and list 2 with a 2 in it, list 3 with a 3 in it. Then we say CPS prime is what? Is a list to CPS of list 1. And then how do we concatenate lists when they're in the CPS version? Do we compose them? Do we just apply them? So let's say that we have an f at the end that just returns empty list. Then when we pass blah, Yeah, that's not the point. The point is when it's in its CPS version. In its CPS version, it's something like so. So it must be a thing where can't. Oh, there, chain CPS. That's it. That's what we want. Yeah, I was like, it's not composed. It must be something a bit more complicated. Indeed, it is quite. Indeed, it is quite. So we compose an A-to-R. It's in a weird way. And an A to a B to R to R in order to get a B to R to R. Oof. Yes, sure. So this is a unit to list of A to list of A right here. And we want to chain CPS it with something. Maybe we chain CPS it like this with a what? With something that expects an A. And what's our A? Well, our A is unit actually. So we have a function from unit to a B to R to R. So we do like list CPS list 2, for instance. And now we have a B to R to R, which I think the idea is that it's composed A and B, or is it just B? Oh, right, no. Yes, okay. So it gets the A, which is unit, and then it returns. I think this will absorb list 1 and only show list 2. So I do want to compose those guys. And so then I'm a bit confused about where to put things. Okay, let's look at how monoid to CPS here looks like. So it ignores the thing. Oh, maybe it's reversed. Maybe that's nil. Yeah, maybe it starts with nil. Or the CPS version of that, or so. Now let's keep it like that. And then it chains to, let's say, list 1. And let's write it in a similar style. And it chains CPSs, let's say list 2 and list 3. And then we print CPS prime const. Well, I suppose we still need to pass it something. Except that in this case, I think it will be ignored. But yeah, let's try. Yeah, everything's ignored, including so it just returns this. So apparently the rest doesn't occur. Take another look. does the monoid to CPS here. So I mean, we could list to CPS, but maybe I have oversimplified this. Maybe list, I do need to list to CPS. Maha. Excellent. I did need to list to CPS. And so what if I put 9 here? Is it going to be 1, 2, 3, 10, 9 or 1, 2, 3, 9, 10 maybe? I'm thinking 1, 2, 3, 9, 10. Place your bets. Not. Yes, it makes sense. It makes sense. It makes sense. Okay, so we are doing things with our CPS representation of lists, and I think by doing that we are learning a bit how this whole H3 thing might work. But this is where I'll stop because, you know, I woke up very early this morning and I've had a full day of work, and yeah, that's not a lot of progress, but that is learning about CPS style and this type of and moving list to CPS. And so why is that useful for what we were doing? Because maybe, just maybe, this nil, which in this example was kind of const here, maybe that's where we recuperate a kind of, or like an isomorphism of sorts between this more concy nilly representation of the free arrow into with this cons here and this pure AB that is kind of nilly. That we reconcile this with the CPS version, and so maybe that will allow us to see more clearly into what we do. I mean, if what composition? I mean, holy moly! Actually, maybe that's just in the category instance of HH3. Let's see if it is. HH3, hello, and category, and let's see. ID and blah, HH3 blah blah. So composing HH3F with HH3G, XK does this thing where H is CG, so it's using the category instance of G, yes, and then GBD, GAD, GAD. It's tough to see without unrolling the H3 types. Let's see. In our case, this would be something a little bit like this, right? This is where we sort of what we're expecting here. So, okay, so we start with this and we say, in fact, we call this A and we call this R. How about that? So this becomes R and this becomes R. And then we say this is XY. How about it? Okay. And now we don't have redundant things. And so we go from A to R to R. And really what we are doing here is we're going to from Rx prime Ax prime y prime to Rx prime y prime to Rxy, which is quite a bit like A to R to R, which is our first thing. And so what we're saying then is that we also need something like an A to a B to R to R. And so what would that thing be? It would be something like for all, well, it would be this, well, no, it would be for all, oh, what is G? It's R, right? So for all R, or R, it would still be R. Here would be, oh, yeah, I'm missing an arrow here. It would be what? A x prime y prime to, well, you know what? We don't need to do the expansion here. Do we not? Do we? Ooh, yeah, no, actually, maybe we do, because it's not clear where the ranks are going to be here. We might need to do our x second, y second here, maybe. To our x, what, prime, x prime, I have no idea. Here we had different types here because there's a for all implied by this. I didn't write a for all here, but so here it's there, and then here clearly it's there, so that needs to be of higher rank. That's fine, but then maybe the A and the R here are indeed of the same rank, in which case I think I did this seemingly properly. But yeah, the question is then, what does this become next? Seems like we could do like blah tilde tilde R. That's fine, that follows the model. But then it seems like we would need to keep our variables here, because, well, first of all, we need an arrow here and an arrow here, but we can't put a natural transformation anywhere in between this. In fact, I might be wrong there, because these might be different x's and r primes. But anyway, so at some point with what we're supposed to be more or less at the point where we kind of see R here, and so what? Whoopsie. So if we go back to, let's say, H now instead of G, then we have H here, and H here, and then maybe, is it going to be BC or is it going to be AB? Huh. Or is it even going to be CD? Well, let's start with CD. Here we could imagine that that's actually what, GAB, maybe, I have no idea. And so here that's G to H. And so I'm trying to see that maybe there is, you know, like something that looks like this composition right there. So from F to G with something that then takes the G to H, and that as a result we get some kind of well, in our case we get an, do we just get an HCD? What is it that we get? Oh yeah, we get just this actually. Yeah, so it's not a super exciting thing to get. that's what we get. And maybe it's exciting. Maybe we do this like this. Do GH and CG. Aha, maybe we have CG and CH? Probably we do. And then this, and then no, this, yes. So let's further. So how does this work? It works like this, I believe. Ta-da, ta-da. Yes, and then this and this. Let's do this guy in the same form. I think it reads better like this, doesn't it? And it feels like monadic composition, which is probably why Conti, maybe Conti adds an M somewhere there. But yeah, I suppose it feels like monadic composition or just composition. I suppose these monads don't have anything to do here yet. So let's try and get this maybe aligned the same way. Yeah, kind of like that. I am not sure about this return type here. It could be that actually it's the same AB. I don't even know what exactly that means, but that seems like some kind of, yeah, some kind of way to, I don't know, to compose. I mean, in theory, it's the same thing as this, I think. Is this sort of, it's the category instance, right? I think this is dot, is it? No? Takes a GAB here. That's not the same. Shouldn't it take a FG? A to R. A to R. So that should be some kind of F. What is this? This is not right. A is F. So it should be F. Okay, well, that's the only A. So that's fine. So FAB, but this is R. Yeah. Oh, everything returns to R there. So yeah, no, I definitely made a mistake here. So if it was the same, you would need to go back to, it would need to be Well, to be honest, it would need to be some kind of R. And so then that kind of makes more sense that it would be AB here, I think. Yeah. That seems to make more sense, maybe. We get a natural transformation from F to R. That's all that continuation stuff. So in fact, in our case, R is arrow pretty much all the time. Yes. So it kind of makes sense. So we have all things that we know how to map to arrows. And we can compose these things without yet having the arrows. So that's the equivalent of that free thing where we can sort of append them by using this chaining. Okay, now I'm wondering whether this also has something to do with arrow notation and the fact that evaluating an arrow might return something in proc notation, like A, and then passing that A down to the next thing is exactly what's happening here. Except it makes sense with an A, but now we have a whole FAB. It's not really that we have a whole FAB. That we have something that takes an FAB and returns the G. I think this, we need to work more on this. Let's write down some notes and finally close this. I couldn't stop. So we didn't try, holy moly. Looks like we're again creating some work from the top, or inserting our ideas at the top. So okay, try to understand lists and CPS. So we definitely tried. Succeeding is a whole different matter, but we're kind of there. Second would be to then apply to find parallel between this whole business of blah and nil and the this FG CPS for free arrows, for H free. Okay, so that's kind of where we want to find the parallel. It's kind of where we leave things, and then what would be the intermediary step? Like once we have that, then what do we do with it? We then try again to do to think about to think about load, possibly as we try to reinterpret the load, this load, into the CPS style. That's what we do. Squint at blah, whoopsie. No. Okay, still no. I see. Didn't copy correctly. CPS it. All right. And then we go back to try component and all of that stuff. But that's the new intermediary steps. And that's where I leave it for today. Thank you very much for watching, and see you next time on stream. Bye-bye.